Hello, my name is Kaley.
And I'm Sara.
And today we're going to talk about nomenclature of coordination compounds.
Before we discuss naming the coordination compounds, we're going to talk about what they are.
So, a coordination compound is usually, for starters, is they consist of a complex ion, which is usually composed of a metal cation, and it's bonded to neutral ions, which are usually anions or ligands.
Just like other compounds we've learned in other previous chemistry classes, the charges are significant in the entire complex.
These complexes must be neutral, therefore they must be uncharged. Essentially, their signs must cancel each other out.
Also, within each of these compounds, there must be at least one ion present in the complex.
Before we go more in depth, we're going to now talk about what a coordination number is. So a coordination number is the number of ligands that are attached to the central atom.
Typically, the coordination number there falls 2 to 9 bonds.
However, there are many factors that influence the number of bonds, such as the size, the electron configuration, the charge of the metal cation, and the ligands.
Another integral component that plays a role in coordination compounds is the oxidation number. As we've mentioned previously, the entire complex is neutral.
That's where oxidation numbers come in. So the oxidation number is the total number of electrons that an atom can either gain or lose when it's bonding with another atom.
Now that we've covered those topics, let's go on to naming them.
So first off, let's go over the prefixes. Now I'm pretty sure you guys have heard of prefixes before, so think fast. How many are in a molecule if the prefix is tetra?
Did you say 4? Then you're correct. If the molecule is tetra, that means there are 4 molecules in that compound.
Now let me show you guys the other prefixes that we'll be using. Here are the prefixes for naming the compounds. If you've never taken a chemistry class before, then this might be new to you. If you have, then you may recognize some of them.
So now that you're familiar with these prefixes, let's go over the rules for naming the compounds. Rule number 1, name the cation before the anion. This should be similar since that's what we did with naming ionic compounds.
Rule number 2, name the ligands first in alphabetical order. So when naming a coordination compound, you have to make sure that all the ligands are in alphabetical order. I'm going to show you a list of ligands that you'll be using when you're naming a coordination compound.
So when you name coordination compounds, you have to change the ending of the ligand. So those ending in "ide" are changed to "o", so like chloride is changed to chloro. And those ending in "ate" are changed to "ato", so like acetate is changed to acetato. They sound funny, but it's okay. And then those ending in "ite" are changed to "ito", so like nitrite is changed to nitrito, nitrito, I don't know.
Potato. Okay. And so notice how on the neutral ligands that some of these are pretty familiar, such as water, but notice that their names are not the same. So for water, instead of being water, it's now aqua. For ammonium, instead of being ammonium, it's now amine with 2 M's. And instead of it being normally carbon monoxide, it's now a carbonyl.
Now let's talk about some common metals present in anionic compounds. So notice here that they all end in "ate", and this is because they use their Latin name, similar to their atomic symbol. So iron is Fe, copper, Cu. They're usually the first 2 numbers, except for like lead and tin.
And silver.
And silver, yes.
Alright, so now we're going to move on to rule number 3, which is you're going to name the metal atom or the ion. And when you're writing out the chemical formula, make sure that you put the metal in the very front and the ligands in the back.
Now that we went over these rules, let's just dive right in. So here's our first practice problem. So here we have this compound. So let's break this down step by step. First, we see that the bracket, we have platinum and chloride. So platinum doesn't have a subscript, but chloride does. So chloride has 4, so that means that there's 4 chlorides. So if we refer to the table previously mentioned, you notice that since it has 4 molecules of chloride, we have tetra. So we use tetra as the prefix. Right. And that changes to Since it ends in "ide," it changes to "o." So chloro. And platinum ends up changing to platinate. And we put the metal up in. Tetrachloroplatinate is what we have. And since we have potassium in the front, and there's two, we separate this, and this is all one word, and then potassium, there's only one separation, that's between potassium and the compound. So we have potassium tetrachloroplatinate. Oh, and then because chloride chloride from the periodic table, you know that has a -1 charge. And then since there's 4, you multiply that by 4 and you get -4. Potassium, as you know, it's +1. Since we have 2, that turns into +2. So these compounds have to be neutral. So for it to be 2 plus, and this is, we'll put as x, and -4, this has to equal 0. So just simple algebra, and we use x equals 2 plus. So then we use platinum must be 2. And this is your answer.
Alright, so if you guys got the answer, so good job guys. But now I think we're a little ready for a little bit more intense challenge. So look at this beast right here. It's composed of 3 different molecules, and as you can see that this one actually has 6 molecules on the inside for water instead of having like less than 4. So, like we did in the other problem, notice how that there's a 6 right here for that one. And water usually is known as like a neutral charge, so this is just going to be 0. And cobalt, you have no idea what it is, so that's going to be our x. And then we know that iodide is usually a minus charge. And so you'd multiply that charge by 3, so it's technically like 3 minus. This one's 0 times 6, so that's 0, and you're left with x. So if we do algebra and isolate all the variables, to make 0, then you're just going to get x is equal to +3. So that must be the charge for your cobalt. So when writing this out, you know that for a ligand, you're supposed to make it in alphabetical order. So we have 6 here, so if we refer to our prefix table, we know that 6 means hexa. So when we're writing it out, it will be hexa aqua, because water is no longer water. And then you gotta put your other ligand, which is cobalt, which we said was a +3 charge. And then you put your outside component, which is your iodide. And that is your answer. That is how you name a coordination compound. Just make sure that you guys remember all the prefixes and the common ligands and put it together and you guys will be okay.
Or if you need any more help, a good resource to check out is Nomenclature101.com. This is free student-driven learning course, and if you need any help, it tailors to what your needs are. If you need help with naming or drawing or writing them out, it helps you. So it's good. You should check that out.
Alright, thanks for watching!